Hello Q-steppers and fellow R-coders, and welcome to another tutorial in the series of How to in R. This tutorial follows on from the Multiple Linear Regression Part 1 tutorial, where we covered how to check your variable class and compute a multiple linear regression in R. This tutorial will focus on how to evaluate the model and interpret those coefficient results. Okay, so this is a summary of a multiple linear regression output in R. But what does it all mean? So let's break this output down step by step, starting from the top. The first information in the output just reiterates the code that we have input. So just as a quick reminder, if you haven't watched the prequel tutorial, we had the alcohol variable as the outcome, which is the standardised ratio of alcohol-related hospital stays in each data zone in Scotland. Our first predictor was the depressed variable, which is a percentage of people prescribed mental health medication. Our second predictor was the dummy urban variable, which is analysing the effect on urban data zones over rural data zones. Our third predictor is the attainment variable, which is the score based on school leavers' highest level of qualification. And lastly, our fourth predictor is the income rate variable, which is the percentage of people who receive welfare benefits as they aren't working and therefore are income deprived. Then we have a summary of the residuals. Remember, the residuals are the distance from the data points to the fitted slope. Ideally, this should not be far from symmetrical. Looking at the minimum and maximum value, then the first and third quartile. The median should be near to zero. So this model appears to be non-symmetrical. This means that we may have violated one of the assumptions of multiple linear regression, which will be covered in the next tutorial. So next we have the coefficients. So firstly we check the p-values for the predictor variables. Again, if under the 0.05 threshold, if we are using the 95% confidence level, by checking those p-values, all the predictors are statistically significant in explaining alcohol-related hospital stays, except the attainment variable. So we do not include an interpretation for attainment. Another way to check for statistical significance is if the t-value is over the absolute value of 2, or 1.96 to be precise, then it's significant. Remember, the t-statistics is the estimate divided by the standard error. So now looking at those coefficient estimates, the intercept provides the value if all our predictor variables were held at 0. So if all the predictors were at 0, we would expect alcohol-related hospital stays to be at -26. However, we never really include this in the interpretation. So to interpret the depressed variable, we could say, first, for a 1 unit increase in the percentage of people prescribed mental health medication in a data zone, we can expect the standardised ratio of alcohol-related hospital stays to increase by 0.8, while controlling for other variables. Now this last statement is derived from a Latin saying of ceteris paribus. Hopefully I've pronounced that properly. This just means that we are taking the other predictor variables into account, and we should only include this after the first interpretation of the model. For the urban interpretation, now remember this was your dummy variable where urban was the higher value, so to interpret this, we could say that urban data zones in Scotland are expected to have higher ratio of alcohol-related hospital stays than in rural data zones. Or you could change it into urban data zones are expected to have a higher ratio score by 15 than rural data zones in Scotland. So if you recollect, our attainment variable was not significant, so we do not include an interpretation. We'll move on to the no qualification interpretation. And that rhymes. So we could say for a 1 unit increase in the ratio of working age adults with no qualification, the ratio of alcohol-related hospital stays are expected to decrease by 0.18. Or we could say data zones with a higher prevalence of working age adults with no qualifications tend to have a lower ratio of alcohol-related hospital stays. However, the effect is really small, suggesting that the ratio of working age adults with no qualifications only matters slightly in our model. For the income rate interpretation, we could say for a 1 unit increase, the percentage of adults who are income deprived, the ratio of alcohol-related hospital stays are expected to increase by 8% in Scottish data zones. Or we could say data zones with a higher prevalence of working age adults who are income deprived tend to have higher instances of alcohol-related hospital stays. So that's our interpretation for the coefficients. So let's move on to the next part of the output, which is the r-squared and the f statistic. So the bottom information reveals the f statistic p-value. This is generally what we would look at first in our output. So the p-value is under 0.05, therefore our overall model is statistically significant. Next, we look at the r-squared and the adjusted r-squared. With r-squared, we can interpret that our predictor variables explains 54% of the variance of alcohol-related stays in Scottish data zones. So the adjusted r-square takes into account the amount of predictor variables in our model. Ideally, this value should be very close to the r-squared, which it is in this case. So the residual standard error reveals the standard deviation of the residuals in the model. So when we have small values, this means that our predictors are more reliable. So let's have a look at that full summary output again. Just to reiterate, we firstly look at the f-test p-value. It's under 0.05, so our model is statistically significant. Our r-square tells us that our predictor variables explain 54% of the variance in alcohol-related hospital stays in Scottish data zones. Then we check the p-values of our predictor variables, and if they are statistically significant, we include an interpretation. So hopefully this tutorial has got you familiar with how to evaluate and interpret multiple linear regression in R. So coming up next is part 3 of multiple linear regression, and we will be checking the assumptions of multiple linear regression. So happy coding, Q-steppers, and remember to subscribe to your social media channels, and thank you for watching.